Good morning, this is your Stat Sensei, Mr. Spensei, and this is a warm-up on two-sample T, and this is going to be a two-sample T hypothesis test. There's our formula right there, and it's on test scores. So a high school wanted to know which new curriculum would result in the highest test scores. 20 students were randomly assigned. I'm glad I told us it was random, and it's also important to set assignment to one of the two programs being considered. The after program results are found in the table below, and the results are normally distributed. Hey, that's nice to know too, because that tells me if they're normally distributed, that takes care of condition three. Now it says 20, and if I were to count this up, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 for program A and 10 for program B, and 10 and 10 gives me 20. So that's where the 20 came from. So really there were 10 assigned to each group. Okay, so or to each program, and they were randomly assigned, and we'll get back to that in a moment. So it says for each sample, write the parameter and list the inputs. Well, they didn't actually give me all the inputs I need. They didn't give me X bar one, they didn't give me X bar two, or the standard deviation of the first or second, etc. So I input that data in the stat edit, and there's actually a couple things I can do. I can go stat calc one var stats, and I'm blue one will give me for program A. And I find out the sample mean is 81.5. And I have a sample standard deviation of 5.93 and a sample size of 10. Now, if I go back to stat calc, one var stats, and change it to L2, I get 75.5. The standard deviation is 6.204. And there's my sample size of 10. Now, there's another way to do that, and I want to show that as well, is I can go stat test to number 4, two sample t-test, and I have data, L1 and L2. I've chosen not equal, and here's why. They use the word difference, and the word difference lets me know that, hey, this test they did not give me a greater than or less than. They're telling me, hey, they want to know which one's different, uh, or is there a difference between the two? All right. And so then we never pool. We press calculate, and I notice there's X1, there's X2, there's standard deviation 1, standard deviation 2, and there's my sample size 1 and sample size 2. All right, now that we have that information, we can plug this into our formula. So X bar 1 in for 81.5, the test score is 75.5. There's our standard deviation squared for each one of them and our sample sizes, okay? So our first parameter, let mu equal the true population mean test score or test results for program A, and let mu2 equal the true population mean test results for program B. All right. For our conditions, we really have random assignment, for both. All right. So we really have random assignment for both of these. And because of that, we really don't have to say the independent part because if it's randomly assigned, they are independent. But we have two independent random samples because they were randomly assigned. And they're randomly assigned of 10, and we say the word given. Also, normally we have to check the n is less than 10%. And we'd go, okay, 10 times 10 is 100. But in this case, we don't have to worry about a population size because of the random assignment. So technically, this condition right here, the n is less than 10%, is not needed because of the random assignment. When we have random assignment, we don't have to check the n is less than 10% condition. For normality, we normally want to check to see if it's large enough, if our sample size is 30 or more, and then it'd be normal by central limit theorem, but that's not the case. Fortunately, they told us it was given normal, and that was given. Had they not done that, I would have had to go make a stat plot, and I'd have to do it for each one of them. So if I turn this first stat plot on and I go to box plot and zoom 9, oh, guess what? My box plot looks reasonably symmetric and mound shape. Then I'd go back and do the same thing, second stat plot, and I could go ahead and turn the second one on, choose the box plot, and this time blue 2, and I'll go zoom 9, and you can say, hey, look at the two box plots. Both of them, they're not perfectly symmetric, but they're reasonably symmetric, and there's no outliers. So the big thing is it was random assignment of 10. So that gave us two independent random samples. We don't need to check the n is less than 10%, and the normality condition was already given to us. All right. I hope that helped, and I look forward to seeing you on the next one. Thank you.